Now the next question is draw the electron dot structure for the following. The first one is given for the ethanoic acid, that is acetic acid also. And before drawing its structure diagram, first of all we have to be know the formula, chemical formula for the same. So the chemical formula for it is CH3COOH. This is a chemical formula for this because ethanoic acid is based on ethane and oic functional group, and the oic functional group is COOH. So to draw its structural diagram, first of all the carbon-carbon compound that is there is in number, it's 2. So I will first of all take that carbon atoms, and accordingly I will take the hydrogen atom also. So this first C is having 3 hydrogen atom, and the center one carbon is having double bonding with oxygen and single bonding with OH group. So this is the complete diagram for it, complete structure diagram. You can also draw its electron dot structure. If you know the number of valence shell present in each of its atom, we know that in a carbon there are the 4 electrons. So accordingly I can present that 4 electrons through a dot for both of the carbon atoms. So both of the carbon atoms having 4 electrons. And for hydrogen and and oxygen, I will represent it by different sign. So for hydrogen, I will represent it by cross. So in a hydrogen having only 1 electron to share, so it will be represented by cross. So accordingly, the each hydrogen atom will share its 1 electron with carbon. So they will be represented by cross. And here also a 1 hydrogen atom is there, but before that there is oxygen also. So that's why I have to take first of all the oxygen, after that I will take the hydrogen. So I will rub it. So I will, instead of taking hydrogen, first of all take oxygen, and after that I will take the hydrogen because it's a OH group. Here also I will take the oxygen, but the oxygen do not having the 1 electron in its valence shell, it's having the 2 electrons. So that's why accordingly it will be share its 2 electrons. So the carbon, instead of sharing any of its electron here, it will be shared here. So I will shift that electrons here, and that carbon atom will share its 2 electrons with the 2 oxygen electrons. So that's why I will rub that particular, and after that this oxygen will share one of its electron with that carbon atom. If I name it like a C2 or C1, so oxygen will share, because oxygen has the valency 2, so it will be share one of its electron with the carbon present here, right, and one of its electron with the hydrogen present here. So this hydrogen will share one of its electron with this oxygen, and this oxygen is share one of its rest electron with the carbon. So there is a single bonding here and single bonding here, but double bonding is there only. So in this complete structure there is a double bonding here only. In the rest of the places there is only single bonding. So in that way you can draw the diagram. So the next one is for H2S. H2S. In H2S there is a 2 hydrogen atom and single sulfur atom, and hydrogen having the valency of 1, and accordingly the sulfur is having the valency of what? What is the atomic number of sulfur? Hydrogen, helium, lithium, bromine, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur. So sulfur is having the atomic number 16. Hydrogen having 2 atoms, and hydrogen having the atomic number is equal to 1, and sulfur having the atomic number is equal to 16. So accordingly the configuration of hydrogen is 1 only, but for sulfur it is I will rub it and I will mark here an arrow. So for sulfur the atomic the electron configuration is 2, 8 and 6. So the sulfur has the 2 valence electron. So to draw its electron dot structure we have to know that. So I will take the two hydrogen atom H and H, and in between I will take one sulfur. So sulfur will share one of its electron with one electron of hydrogen and one of its electron with one electron of hydrogen. So hydrogen electron is represented by cross and sulfur electron will be represented by dot. So accordingly, one covalent bond will be there, a single covalent bond, and single covalent bond will be there. So there is a single sharing of electron. So this is a structure for H2S. For the next one, here is a propane. Propane. So in a prop, there is a three carbon atoms. So propane, that means to say there is a, for a prop there is a three carbon atom. So that's why I will write down C3 here. And for propane, there should be a 8 hydrogen atom. But we will replace the number of hydrogen atom of 8 to 6, and we will add one group here, that is a CO, because one is there, so it is a from cation, and the cation is CO, represented by CO. The chemical formula for cation is a CO. This is a functional group, so that's why the number of hydrogen atom will be reduced to 6. So to draw this diagram, for this I need a space, so that's why I will firstly rub it. Now I think so I have the enough space, so I can draw its electron dot structure. So for C3S6Cu, I have to draw a structure for propane. So accordingly, first of all I will take the three carbon atoms C1, C2 and C3. This will be a C1, this will be C2 and this will be C3. Accordingly, first of all I will write down the three hydrogen atom here with that C1, because that 3 electron of carbon will be shared with this 3 atom of hydrogen, and 1 electron of that carbon C1 will be shared with C2, and C2 will be shared its 2 electron with the oxygen, and 1 electron with the C3 and 1 electron with C1, and the rest of C3 will share 1 electron with the C2, 1 electron with the hydrogen, 1 electron with this hydrogen and 1 electron with this hydrogen. So this will be the complete structure diagram for it. So if you know that structure diagram, you can draw this one also. The only difference is there is electrons are represented by dot and cross in that. So that's why it's known as electron dot structure. Otherwise, this one is also a structure diagram for propane. This is not a wrong, but this is not an electron dot structure. You can draw this diagram from this also, right? So you can do that also. So for C1, C2, C3, I will firstly write down their valence electron by dot. 1, 2, 3 and 4, 1, 2, 3 and 4. So every carbon atom has 4 valence electron. So this hydrogen first will share its electron represented by cross with the C1. This hydrogen atom will share its 11 electron with C1 represented by cross. This hydrogen atom also shares 1 electron represented by cross with C1. C1 share one of its electron with C2 also. So that's why the dot dot structure will be there. Otherwise, this center C2 will not share any electron in the bottom side. So that's why I rub this dot. It will be share its 2 electron with oxygen, because oxygen has the valency 4. So oxygen will be shared its 2 electron with the C2 and make a 2 sharing of electron in between O and C2. And this C2 will share one of its electron with C3 and one of electron with C1. And this C3 also share one of its electron with the one hydrogen atom and one of its electron with the another hydrogen atom represented by cross, one of its electrons with the another hydrogen atom. So in that way you can draw also the electron dot structure for it. Now we are left with the F2, that is a fluorine. And what is the atomic number for fluorine? Hydrogen, helium, lithium, bromine, boron, carbon, nitrogen, oxygen, fluorine. So it's having the 9 number. That means to say fluorine having the atomic number equal to 9. So what will be the electron configuration for it? It will be 2 7. So that means to say it's having the 7 electron in its outermost shell. So it need a so fluorine in 1 electron to get octet. So that's why the 2 atom of fluorine will share one of its electron with each other. So that's why its electron dot structure will be like that. They will be share one of each electron to be get octet. So that's why its name is F. The next question is, what is a homologous series? Explain with an example. The homologous series is relevant to the carbon compounds that are different from them by just carbon and hydrogen atoms, number of hydrogen and carbon atoms, right? Otherwise their properties are same. So as written there, the homologous series is a series of carbon compound that have different number of carbon atoms but contain the same functional group. For example, methane, ethane, propane, butane, etc. are part of alkane homologous series. The general formula for this series CnH2n plus 2, that is written there. And according to the general diagram, you can count the number of carbon atom, number of hydrogen atom present in that series. So this is called the homologous series, where the functional group is same, but the number of carbon and hydrogen atom can be different. How can ethanol and ethanoic acid be differentiated on the basis of physical and chemical properties? Ethanol and ethanoic acid. Ethanol and ethanoic acid is basically if the oxidation of ethanol is happen, then it become a ethanoic acid, right? Ethanol is an alcoholic group and ethanoic acid is a oic group. Ethanol is a liquid at room temperature with pleasant odor, while ethanoic acid have vinegar-like smell. It is having very intense smell, so that's why it is different physically from ethanol. The melting point of ethanoic acid is 70 degrees Celsius. This is below room temperature, hence it freezes during winter. Ethanoic acid react with a metal carbonate and metal hydrogen carbonate, but ethanol do not react with that. There is the same thing is given there. When metal carbonate and metal hydrocarbonates are there, the ethanoic acid is from carboxylic group, so that's why it will give salt, water and carbon dioxide. Otherwise, if the alcohol is there, there will be no reaction take place between the metal carbonate and metal hydrocarbonate. That is represented there. This is a chemical reaction for ethanoic acid CH3COH with sodium carbonate. It gives us water, carbon dioxide and this salt and sodium anthracite. On the other side, if alcohol like CH3CH2OH, right, when react with sodium carbonate, there is no reaction take place.